All right, everyone, it's time to stretch a bit. We're about to dive into the really exciting stuff, generative AI, or Gen AI for short. But before we get into that, I just want to say how glad I am that you've all hung in there with us so far. We've laid a strong foundation, covering the basics of AI and machine learning, and now you're equipped with the knowledge you need to really understand what makes Gen AI so fascinating. This next part is where we see AI not just learning and making decisions, but creating and generating new content, pushing the boundaries of what we thought was possible. So, take a deep breath, get ready, and let's explore the world of Gen AI. As we enter part 3 of our course, focusing on generative AI, let's take a moment to reflect on a significant milestone in AI history. November 2022. This was the month when AI truly took a leap forward with the launch of ChatGPT, which saw an astounding 153 million visits on day one alone. From that point on, the world saw just how powerful and accessible AI could become. In December 2022, ChatGPT's popularity surged, reaching 265 million visits. By January 2023, traffic had more than doubled to 615 million visits, showing the rapid adoption and fascination with this technology. The growth didn't stop there. In February 2023, ChatGPT hit 1 billion visits, earning the title of the fastest-growing consumer app in history. By March 2023, it reached a peak of 1.56 billion visits. And even in June 2023, it maintained its position as one of the most visited web domains with 1.5 billion visits. These numbers aren't just impressive. They highlight the massive impact AI is having on our daily lives. This is why understanding generative AI and AI in general is so important. The technology is not only here to stay, but is rapidly becoming a central part of how we live, work. Now, let's talk about large language models, or LLMs, which are a powerful form of generative AI focused on natural language processing, understanding, and text generation. So, how do they work? LLMs are trained on massive amounts of data and use a technique called self-supervised learning. This allows them to predict the next word or token in a sentence based on the surrounding context, making them incredibly effective at understanding and generating human-like text. To give you an idea of their impact, LLMs like OpenAI's ChatGPT have been revolutionary. In fact, ChatGPT has become the fastest-growing app in history, reaching 100 million users by January 2023, just a couple of months after its launch in November 2022. The cultural impact of LLMs has been profound. Bill Gates called this technology revolutionary, and Credit Suisse described it as transformative. We've even seen AI-generated content, like an imitation of Eminem rapping about cats, that highlights just how far this technology has come. And it's not just fun and games. LLMs have proven their capabilities in serious contexts too, like passing challenging exams, from the Uniform Bar exam to the S8, GRE, and even the Wharton MBA exam. This shows the incredible potential of LLMs in various fields, from education to professional certifications. In short, LLMs are changing the game in how we interact with technology, and their influence is only going to grow from here. If I have to explain, LLM is a simple way. Imagine a person who has read most of the information on the internet. They can remember key information, understand the basic structure of how content is generated, grasp grammar intricacies, and recognize the kinds of questions people ask and how they receive answers. This person, with their vast knowledge and understanding, becomes an invaluable resource for others, able to quickly provide accurate information, offer insights, and generate coherent responses to a wide range of questions. Similarly, a large language model, LLM, can help a person by serving as a digital counterpart to this knowledgeable individual. The LLM processes vast amounts of text data, learns patterns, and generates responses that are contextually appropriate and relevant. It can assist with answering questions, providing explanations, generating content, and even offering creative ideas, all by leveraging its extensive reading and understanding of language, much like the well-informed person in the analogy. Let's dive a little deeper. In this section, we're going under the hood of LLMs to explore how these models actually work. We'll break down the key components and mechanisms that enable LLMs to generate such impressive and human-like text. This part will give us a clearer picture of the technology driving tools like ChatGPT and help us appreciate the complexity and innovation that goes into these models. By the end of this section, you'll have a better grasp of the inner workings of LLMs, making the magic behind AI a bit more tangible. The sequence-to-sequence model. When you're typing a message on your phone and it suggests the next word based on what you've already typed, that's a sequence-to-sequence model in action. This model predicts the next word in a sequence by considering the words that came before it. In this model, the sequence of input words is processed to generate a corresponding sequence of output words. This approach is particularly useful for tasks like translation, where the input might be a sentence in one language and the output is the translated sentence in another. The model is trained on vast amounts of text data, learning patterns and structures in the language, so it can predict what word is most likely to come next. This predictive capability is at the heart of many AI-powered text generation tools we use today, from autocorrect on our phones to complex conversational AI systems. While modern models have evolved to be much more sophisticated, the sequence-to-sequence model is a critical building block that laid the groundwork for today's advanced language models. All right, let's talk about one of the key technologies that makes modern AI so powerful: transformers. You might be thinking of the robots from movies, but in AI, a transformer is something quite different. Transformers are a type of model architecture that has revolutionized how we process and understand language in AI. So, what makes transformers special? In simple terms, transformers allow AI to handle and make sense of large amounts of data very efficiently. They do this by focusing on the relationships between words in a sentence, regardless of their position. This is different from older models that had to process words one at a time in order. Imagine you're reading a sentence. With a transformer, the AI doesn't just go word by word, it looks at the whole sentence at once, understanding how each word relates to every other word. This is what we call attention in AI, and transformers use multi-head attention to do this multiple times in parallel, making the AI much smarter and faster at understanding context. This architecture is the backbone of many advanced AI systems today, including the large language models like GPT that we've been discussing. It's why these models can generate such human-like text and handle complex tasks that require deep understanding of language. In essence, transformers are like the engine under the hood of a high-performance car, making AI not just possible, but incredibly powerful. Now, I know it feels like I might be taking you into a few rabbit holes here, but I promise these small turns are important. They'll help you understand the building blocks of large language models much better. So just hang in there with me. We're almost there. We're almost there. Just one more turn, and we'll be out of this rabbit hole. But trust me, understanding attention is crucial for grasping how LLMs work, and it'll all make sense soon. To help explain this complex concept, let's use an analogy. Analogy: a group conversation at a party. Imagine you're at a party, and there are many people talking around you. You're having a conversation with a friend, but you catch snippets of other conversations that might be important or interesting. Even though you're focused on your friend, your brain automatically tunes into certain words or voices around you that seem relevant to your conversation. In AI, just like you selectively pay attention to important parts of surrounding conversations, self-attention in AI helps the model focus on the most relevant parts of a sentence or sequence of words. Step 2. How self-attention works. Analogy, highlighting key parts of a sentence. Imagine reading a sentence like, "The cat sat on the mat because it was tired." When you think about why the cat sat, your mind automatically connects tired with sat. Even though tired is at the end of the sentence, you know it's the reason the cat sat down. Your brain highlights tired as important. In AI. Similarly, self-attention lets the model examine all the words in a sentence and determine which ones are important in relation to each other. It doesn't just read the sentence word by word. It looks back and forth to see how each word connects to the others. Step 3. Why self-attention is powerful. Analogy. Understanding a complex story. Imagine reading a mystery novel. Early in the book, you read about a small detail, like a missing key. Later, when the key is mentioned again, you remember it and understand its significance to the plot. You didn't just forget about the key because it was mentioned pages ago. You kept it in mind. In AI, self-attention allows the AI to remember and weigh the importance of words and phrases from earlier in the text when making sense of the whole sentence or passage. This helps the model understand complex relationships and produce more accurate predictions or translations. In summary, self-attention in Transformers is like having a conversation at a party, where you focus on your friend but also catch important details from other conversations. It allows the AI to highlight and connect important words and ideas throughout a sentence, making it better at understanding context and relationships. This ability to focus on key parts of information is what makes self-attention such a powerful tool. All right, let's zoom out and break down how these large language models, or LLMs, like ChatGPT, learn to generate such coherent and meaningful text. The process happens in 3 main stages. 1. Pre-training. Think of this step as learning the basics. The model starts by reading through an enormous amount of text, what we call an unlabeled corpus, which is essentially just a vast collection of written material from books, articles, websites, and more. During pre-training, the model learns to predict the next word in a sentence, similar to how you might guess the next word in a text message. By doing this over and over across billions and trillions of examples, the model gets a good sense of language patterns, grammar, and context. This is like the foundation on which everything else is built. 2. Instruction. Fine-tuning. Now, the model needs to learn how to follow specific instructions. In this stage, the model is trained on examples where there's a clear prompt, like a question or a command, and a correct response. This is like teaching the model how to answer questions in a way that makes sense. It's similar to how we might teach a student by showing them examples of questions and the right answers. The model fine-tunes its understanding based on these examples, becoming better at following instructions and generating relevant responses. 3. Reinforcement learning from human feedback. Finally, we add a layer of human touch. After the model has been fine-tuned, humans step in to give feedback on its responses. If the model's answer is good, it gets a thumbs up. If not, it gets guidance on how to improve. This feedback loop helps the model get even better at understanding what humans really want when they ask something. It's like having a coach that helps you refine your skills to be the best you can be. So, by going through these 3 steps, learning the basics, practicing with specific instructions, and refining with human feedback, the model becomes incredibly powerful and capable of generating text that's not just accurate, but also meaningful and contextually appropriate.